This is the NEET 2019 question from Mechanical Properties of Fluids. Problem is like this. A small hole of area of cross section 2 mm square is present near the bottom of a fully filled open tank of height 2 meters. Let me stop there for a minute and describe what is the meaning of that is, right? There is a fully filled open tank like this, and at the bottom of that there is a small hole, this one, where the tank height is given to us as 2 meter. Thinking G as 10, the rate of flow of the water through the open hole would be nearly, right? So what he is saying is this tank is filled with water up to a height of 2 meters, and through that hole water is coming out. What is the rate of flow of the water? Even if you don't understand what do you mean by rate of the flow, look at the unit. It's meter cube per second. So what he is asking is how much is the volume of the fluid coming out per second. D volume per second is how much. How much volume of the fluid is going out per second is what he is asking you to find out, right? So to get that, first of all, we can try getting some other things like mass of water coming out per second could be written like dm by dt. d by dt of mass can be written like volume into density. d by dt of volume can be written like area into length and density. Area and density are constant. I can write dl by dt. dl by dt, displacement by time, could be called as velocity. Be careful, this is not the volume, this is velocity. So dm by dt is area into rho into density into velocity. I can call it like a v rho. d by dt of this mass can be written like as density is mass by volume. Mass can be written like density into volume. So mass can be written like density into volume by dt. Rho is constant that can be written outside. Of course, dt is already here. Rho d volume by dt could be AV rho. Rho and rho can be cancelled. That implies rate of volume or rate of flow could be written as A into velocity, where A is the area of hole, velocity the velocity with which it's coming out, called it's actually velocity of Fx. So calculating AV gives you the answer. I could have directly given you the formula, but that's not the way that I teach, right? I want you to know from where the formula is coming. That's why I have derived a formula. So area means pi r square, where r is the radius that is given for you. But what is velocity? I don't know. Velocity I can find out using a theorem called Bernoullies theorem. I'll quickly derive that velocity for you, right? By taking again that kind of the system. At this point on the top and at the point at the bottom where water is filled, I do apply a theorem called Bernoulli's theorem at the point x and at the point y. Applying Bernoulli's theorem says that P by rho or P1 by rho. At this point, P is nothing but atmospheric pressure, P naught by rho plus GH. At this velocity at this point is V1 square by 2. At the bottom, pressure is P1 plus this is filled up to a height H. That also creates a pressure. So pressure due to the water by rho, P naught by rho plus pressure due to the water by rho plus GH, assuming the height is small, gravitational potential energy is same, plus V2 square by 2. P naught by rho is same, GH by same, and as per the equation of continuity, this area is A1, this area is A2. A1 is very much greater than A2. A into V is constant, A1 V1 equal to A2 V2. As A1 is very much greater than A2, V2 is very much less than V1, that is V on the top. So, because area on the top is large, A1 is very much greater than A2, automatically V1 is very much less than V2. Thus, I can ignore this part. This V1 is very small. V1 square is also very small. This is just an application of Bernoullies theorem you might have learned. So, entire RHS has gone. So, what is remaining is P of the water by rho plus V2 square by 2 equal to 0. So, V2 square by 2 equal to pressure of the water is HdG, H rho G by rho, rho and rho will cancel. So, V2 equal to root 2 Hg. It's like a freely falling body's velocity. Now, that is the velocity V2 we have already calculated. This is what we have calculated. Now, I can come to the data. So, rate of flow, volume per second is pi r square into V means root 2 GH. So, pi, radius is given to A as 2 millimeter, 2 square is 4, millimeter square is 10 power minus 6, 2 G into 10, H is also 10. So, pi into 4 into 10 power minus 6, this is root 400, that is equal to 20. 20 into 40 is 80, 80 into pi is 10 power minus 6. So, 80 into pi is approximately, pi is 3, so approximately that is equal to 240. Well, I missed the little calculation here. Let me do that calculation once again for you quickly. Yeah. What we have to calculate, everything is same, but we have to calculate the calculation that is equal to pi 3.14 r square. Yeah, what I have missed is I need not do pi r square because he has directly given you the area of cross section. What he has given to you is area of cross section. I need not do pi r square at all, right? So pi r square is already given for you. I need not do that pi r square again. So what I have to do is volume per second is, though area is pi r square, he has not given radius, rather he has given area. So I don't need to do this. I can write area into velocity, that is area into root 2 GH. Area is 2 millimeter square, that is 2 into 10 power minus 6. 2 into G is 10 and H is also 2. That is 2 into 10 power minus 6 into root 40. Root 40 is little more than 6. 6.2 or 6.3 into 10 power minus 6. So it becomes some 12.6 into 10 power minus 6. That's the answer. Right? Meter cube per second. I messed up with the calculation. And the last, be careful about it, right? So to solve this problem, actually, I could have used this formula directly, right? But I have not done that. I just have derived the reasons behind each of this formula, that why you got this 2GH, which is called as flux, velocity of flux. Actually, this is a derivation called velocity of flux. You must have learned it as a application of Bernoullis theorem, right? Once if you know that, it will become easy for you to solve the problems right from the scratch. That's the intention, right? That's it. Thank you for watching.